Hello and welcome to another video. So in this video we're going to continue with the system designs, and we're going to be doing design Yelp. Don't know how this is easy. Honestly, for system design nothing's easy for me, so I guess we'll see. Okay, so the requirements here is users should be able to search for a business by name, location, and category. Users should be able to view businesses and their reviews. Should be able to leave reviews on businesses. Alright, then each user can have one review for business and 100 million active users, 10 million businesses. Okay. Alright. So here, yeah, I guess typically if you have a lot of searches, you want to have fast search, you know, like sub, I don't know, 300 ms or something. Let's see. Should be able to, okay, then we want to have that one constraint. Each user can only have one review for a business. And I guess here we can say if we want to prioritize consistency or availability as well. So yeah, this is another one where I think consistency makes sense. Like if someone leaves a review for a business and you don't see it right away, it doesn't really matter. If a new business opens up and you don't see it right away, it doesn't really matter. And yes, you will have sometimes, you know, our business will have like one review and then that second review really changed a lot, but that's rare enough to where like whatever, doesn't really matter. So prioritize consistency, or actually availability. Availability over consistency. So we just want to have eventual consistency. Like eventually we want everything to be in sync, but if right away something is not accurate, it doesn't matter. Because the user won't even know that, right? Like it's not like someone's friend is going to leave a review and then they're going to like immediately look for it or something instantly. So, okay. So let's take a look. All right. Functional. Okay. System. Okay. Non-functional through 4. Okay. Yeah. Seems good. Let's take a look at that answer. Availability, low latency, scalable. Yeah. I mean, I didn't leave the scalable thing because they have the scale. So yeah, I guess it's fine, I think. All right. Core entities. Okay. So we want to have like a business. Right. And I think, I don't know how Yelp works, but let's just say if there's like some chain, we'll treat each like place as a separate one. So we have like a bunch of McDonald's. Each McDonald's location will be its own business and will have its own review or something for simplicity. We're not going to do like an average review across all McDonald's or something like that. And I think that makes sense because maybe some are good, some are bad. You know, if it's like in another country, should have the same rating as one and whatever. And so we want a business, we want a review, and then we want a user. And then we can talk about like the exact information there later on, but I think this is good for now. So let's just go this. Okay, cool. External. Okay, so here, once again, kind of like the first video, we're just going to look at the function requirements and make endpoints for those. So search for a business by name, location, and category. Okay, so this will be a GET request. Maybe like businesses. And then here we're just going to have a bunch of queries. So we'll just have like name something. So these are all going to be optional, I guess, like name something. And then we'll have location something. Whoops. And then what was the other one? Category. So same thing. So it's basically just GET requests with standard params. Category something. Okay. Where name, location, and category are optional. Maybe they put in nothing and they should give them everything or something. I don't know. You can have requirements there, like maybe they need to put in something or whatever. Okay. Next one. Should be able to view businesses and their reviews. So we basically should be able to. So what this will look like is essentially in the UI, you're gonna type in some things like these things. You're gonna hit search. You're gonna get a list of businesses, and then when you click on a business, that business will show you like their reviews and all that information. So this is gonna be like businesses ID, and then what do we want for that? Like reviews. Okay, so maybe businesses ID, and then we want to like see the reviews or something like that. I don't know, whatever, something like that. So this will be a GET request where they click on a business, it'll show everything there. Should be able to leave reviews on businesses. Mandatory 1 to 5 star rating and optional text. Okay. So leave. Yeah, once again, like usually you can just use REST for this, and you want to think about, okay, if I'm leaving a review, am I modifying, am I getting, or am I adding? I'm adding, so it's going to be a post. So businesses ID. Or actually, maybe this one, maybe we'll just leave it like this. Just get all the information on that business, and then here maybe we'll add, because we're essentially leaving a review, so we'll just, this is typically how you have REST. We're adding a review, so we'll just have reviews. And the body here will be a rating. It's gonna be like a number, and a text or something, or like text optional string. Okay, and then we don't need to return anything. Or I guess we need to say what we actually return here. So here we're gonna return a business array, and then here we're gonna return a business plus its review info. So the business might have information, you know, like address, whatever, pictures, blah blah blah. So we'll return all this guy. And then for the post, don't think we need to return anything. Just return successful status or something. Yeah, whatever. Okay, let's see how we did. Okay, consider adding pagination. Yeah, that makes sense. Review without a line break. I don't think I have a line break. Yeah, I guess maybe it read it wrong, whatever. You might want to include more details about the response format, especially the business view endpoint. I mean, I think I kind of did that, so I mean, we can look at what it is. So business, and review. I mean, I kind of did the same thing. And then, okay, so they return the review, but you don't necessarily have to do that. Generally in a post, like, it's up to you. You can return the thing, you can return nothing. Usually in a patch, you return the thing, but yeah, in a post, I guess it can be whatever. Yeah, so this could have pagination as well. So, like, if this, like, imagine they just put in nothing, then we would probably want to have pagination in the request as well. That makes sense. Okay. Let's move on to the next part. Yeah, I think the first video I had was like an hour, so I'm definitely going to try to like speed up there so it doesn't take so long, and just focus on most of these things. Okay. So, actually, okay, I see what the problem I was doing here. So I want to actually zoom out here to like normal, and then I want to zoom in here is what we need. Okay, there we go. Nice. All right, so what's the next part? How will users be able to search for a business? Draw a simple diagram on the whiteboard, explain. Okay, build. Okay, users should be able to search for a business. Okay, cool. So, yeah, so generally, almost always what they recommend, and probably the easiest, is just have like microservices, figure out what your services are, and then go from there. So right now we just need to search for a business, so we'll just start with client. Let's go with this. Client will call an API gateway. And that API gateway will call whatever service. So in this case, it's going to be like business search, something like that. Actually zoom out a bit here. There we go. Okay. So this is going to be like businesses or something. This is going to handle our search, or we can call this like search, not feature, but I guess system or something. Okay. Or search service. Okay. And then, yeah, so this will give us our searches. And then we can have another one that's going to be like the one to leave reviews or something, maybe, or review service or whatever. Okay. Yeah. So let's see here. So users should be able to search for businesses. So they're going to call our search service, and then the search service is going to call, and we're just going to start with something simple for now. DB. And then as far as DB, I just go with Postgres for most things. I think that's fine, but we'll see what feedback we get. The DB will try to find it, and then the search service will return it essentially to the client. So go back here or something like that. Okay. Yeah. So basically, they're gonna make a GET request here, and then that's pretty much it. And then I guess we can maybe talk about what our businesses should be quickly, and like, well, I guess maybe we can detail maybe not our business but our entities a little bit more in detail here. So we can say like users. So the user can have like an ID, and then the other stuff isn't super relevant. ID, it'll have like user info and whatever. And then we're going to have a business. That business will have an ID. It'll have a location, like latitude, longitude, blah, blah, blah. Name, some other stuff. And then we're going to have a review database here. And that review database is going to have an ID. It'll have a user ID and a business ID to connect the two. And then it might have a rating and like a text or optional text or something. That's pretty much it. So, okay. So essentially what's going to happen here is they're just going to call a GET with some whatever. And then right now we're not going to optimize anything. We'll just literally search in our DB, like what are all the businesses in that, I guess category is another one, right? They want a category. So category, location, if we go back to the actual thing here, let's see. If we go over here, okay, so name, location, category, we have leave review. Okay, I think we're good. All right, so essentially this is what we'd want. Yeah, this is fine. Okay, so they're gonna make a, I guess, yeah, I'll just start saying it in here so it doesn't end up being too long. Okay, so what we're gonna do here is we're gonna make a GET request from the client for the business, like search, the businesses we're searching for, with a query string of location, name, category, all that stuff. It's going to hit our API gateway and it's going to call our search service. Our search service is going to check in our DB for businesses that match the name, category, and location, latitude, longitude. And then we will just return those to the client. So we're just going to have a really basic implementation so far. Okay. All right, cool. So adding a rating field to the business. Oh yeah, okay, yeah, I guess you can search on like the rating. Yeah, I guess I haven't talked about, yeah, like maybe for the rating here. Yeah, I guess that's another thing we definitely actually want here is we do want like an average rating. So this is going to be based on the reviews, and then they can also maybe search on the rating, but we definitely need a rating field because like you should be able to search on the rating, and you should definitely be able to get back a rating for Yelp because that's like one of the most key things. So I definitely forgot about that one. Okay, and then we also need to figure out how to calculate the rating well, but we'll worry about that as we go. All right. Users should be able to view businesses. Isn't that what we just did? Search. Oh, okay. Okay. So I guess what would happen here is they'd search for the businesses. Okay, I see. They'd search for the businesses, and then they'd have some list of businesses. Okay, we can just talk about it, speed it up again. Okay, so what's going to happen here is after the initial search for just some kind of search they have, the user is going to be given a list of businesses in the client. Once they click on a business, that's going to spawn off a GET request again with a business ID that will go into our search service, and it's going to go into the DB. And then that business will be found in the DB. And also all of the reviews for that business will also be found. So we're going to return the business and every single review for that business, or we might have like paginated reviews or something like that. And then, yeah, we'll just return all that. So essentially the query is going to be something like select the business that ID matches the search, and all the reviews where the ID is the business, or the business ID equals the business ID of that business. And then we're going to show all that and display that to the user. Okay. All right, nice. How will users be able to leave reviews? Okay, so this is where we're going to need a review service. So we're going to add that in. And once again, keeping it simple, I'm going to call our API gateway. API gateway calls the review service. With that review, the review will be added to the DB. Okay, and then, yeah, basically like this. So let's say this. So a user is going to make a, once they have the business they're looking at, they can leave a review, and then the client will create a post request there for that business ID, and it's going to send that request to the API gateway. The API gateway will call our review service, and then the review service will save that review. It'll create a new review. The ID will be a new ID. The user ID will be the ID of the user. That usually, yeah, I guess I forgot to talk about this. The user ID should probably be in like the headers or something like that. It's typically not in the request, or you can use like a JWT. The business ID will be the ID of the business that they're looking at. The rating will be whatever they said, and then we'll have an optional text. And then we can just return to the user either just a status of 200 or 201, or we can also return the review to them if they want that as well. Let's see how that went. Okay, nice. Yeah, so yeah, I think they talked about so yeah, on this site they talked about like you want to have headers or JWT or something. You don't just put your info in a post request. So okay. How to efficiently calculate and update the average rating for business. Okay. Yeah, so this is kind of difficult. I guess there's a few ways to do this. What we could do is two ways, I think. Yeah. So I think one way is we can have just like some kind of periodic job. So I guess so this DB rating, let's actually think about it, I guess. Yeah, okay. So what we could do one way is just have a cron job here. So we'll put it here. Job, cron job, runs every, I think, I forgot to spell cron like this or something. Okay. So what this can do is this can just run every whatever, like 30 minutes, hour or something. And it can basically just, for every business, get all the reviews, make the calculation, and then update the rating. I think the other thing we can do that would be better, and this will still be eventually consistent, I think, but this will be pretty close, is we can actually just, when we get the rating, we can calculate this on the fly. So I know I guess this is like from LeetCode. So if you want a computer running average, we can just store the total rating and the total number of ratings. And then we can actually just calculate the index, like this rating on the fly. So whenever a new rating is updated, it will just be saved in this DB. Like it will just take whatever rating they gave, increase the business by that, and then tally this thing by 1. And then we can actually just calculate the average, right? So it'll just be total rating over total number of ratings. Maybe that's better. So I think this will work. Now, yeah, I mean, maybe, once again, I don't think this will be like perfectly consistent, but it'll be pretty close. Yeah, so let's just try to go with this. Okay, so what we can do is, for the business, we can include 2 more fields. A total rating and a total number, which will be the total number of ratings. And then whenever there's a new rating for that business, its total rating will increase by that number. And then the total number will increase by 1. So essentially the way to calculate an average is the total over like the number of elements. So we can actually store those in the business. We can just store the total and the number of elements. And then we can actually calculate the rating on the fly. We can probably even actually get rid of this rating thing, and we can just calculate this guy on the fly. And then that way, if a rating gets added, we just update these 2 items, and then we're good. And then, yeah, this will be, I don't think this will be completely consistent, but it'll be very close and very fast. Maybe it froze or something. Not sure. Hopefully it did not freeze. That would be annoying. Yeah, gonna wait a little bit and then refresh if needed. Or actually, maybe just, no, I can't go back. Okay. Alright, let's try to refresh. Okay, now good. Let's go back and see if we can resume it, or maybe like make a new tab. Okay, so if we just go back and see what happens, maybe we have to say that part again. Alright, resume. How will users be able to leave reviews? Okay. Okay, so it looks like we have to say it again, I guess. Okay, just say it really quickly. So what we can do is in the database, instead of storing a rating, we can store the total of all the ratings, and we can store the number of ratings we have, and then we can just calculate the average on the fly. And then that way, every time a rating is added, we can just update those 2 fields. It would be very fast. And then we can just, whenever we need the rating for the business, we're just going to get all this information and then just calculate the average. And that's just like a basic math command. So that'll be very fast. All right, hopefully it worked this time. Okay. Okay. Consider explaining how you would handle. Yeah, so as far as the race conditions, like as long as basically like as long as we're updating this correctly, which we should be able to, because basically when we do an update, we can just say like total rating plus this rating, and then total rating plus this, and there's ways to handle that in the database. Like you can lock the database by like the row or something, but I don't think you even need any locking here. Like I think this will just be fine. The only problem you can have is like if some transaction reads the total rating and then some other transaction reads the total rating, and then they both do an update at the same time or something like that. But you can handle that. You can do like a row lock or something for the total rating, something like that. Yeah, let's take a look at the sample answer. User submits. Okay, so they have versions. Average rating, num rating, row level locking, or optimistic consistency control. Yeah, like I think optimistic consistency control. Well, I guess row level locking is fine too. So if two users submit reviews simultaneously, we could lose one of the updates, or use optimistic. And we fetch the current business data, calculate the new average, attempt to update. Okay, yeah, I think that's the other thing we can do is like if the user's like updating the database and their value is not what it used to be, like I think every value has a version, then we can just like retry updating and then it will just like get the value again and then increase it and so on. I think you can run a query like that. Like you essentially run a query and then if the version's wrong, you just like retry the query. And that will be fine. Okay. User can only leave one review per business. Okay. So let's see. ID, user ID, business ID. Okay, so I think we can just say that. I think this one's pretty easy. Like, we can just say that this user ID and business ID combination can just has to be unique. And I think you can just write this in Postgres actually. So let me zoom in. Don't know why this is so screwed up. All right, let's try to go like this. Okay, so yeah. So we can just say like, oh, it's because I'm using this. Okay. So we can just say like the combination of user ID here and business ID has to be unique. And I think you can just put this into the table. You can basically say like this thing is unique. Okay. So we can just say for the review table that the combination of user ID and business ID has to be unique. I think we can just enforce that into like the table schema here. And then that would be fine. Okay. How do we improve search? Okay. Yeah, so I guess right now, if like I actually had this problem at work. So if you do just like a search, and the problem on a search is like, let's say our business is like McDonald's or something, and they search for like all like this. So this should match, but the problem in Postgres, if you use Postgres, which I would probably use here, is when you do a search with like this, where essentially like the query can be anywhere as part of the like, it's like, I guess just to keep it simple, let's say we can only search for the business name. We're not going to search for like other random stuff. So if we're searching for the business name, like not the category and other stuff, if we search for a part of the business name, Postgres does like a bad job of finding these things quickly if you have a wildcard on both sides. If you search for something like this, I think it's quick because you can find stuff quickly, but the middle doesn't work well. So what you can do, I guess there's like two ways of doing it, and this is basically what we were talking about at work, is one way you could have Elasticsearch, and Elasticsearch is basically used for like full text search. Another thing you could do is you can have I think it's called like a gin index for, basically this will let you search for like full text search. So you make a gin index. I think it's called like a post gin. I forgot exactly. I can look at it later, or you could search for it yourself. But it's called like a trigram index, and this is basically an inverted index on your column, and then this does the search quick. So I think the way to figure this out is basically the size of your data. So once your data is like massive, you're going to want to go to Elasticsearch and like how fast you want it to be. The downside with Elasticsearch is you need to keep Elasticsearch in sync with your actual database. Like your database can't be Elasticsearch. So the upside of this gin index for Postgres is you just add the index and then you just have a faster search. Obviously, it takes longer to make the index every time you put in items and it takes more space, but you're not adding like any more info and you don't have to add Elasticsearch. So I guess we can look at how many like things we have here. So we have 10 million businesses. So we can quickly calculate this, I guess. If we have like 10 million businesses, business has an ID, which I don't know, let's just say that's like, it depends what you use, I guess. Let's say you use a UUID or something that's like 16 bytes. I don't know exactly. Location, that's going to be like, don't know exactly. Once again, let's call it 8 bytes. Name, let's call that like 20 bytes. Category, 20 bytes or 10 bytes or something. Rating is just like one number, so it's just like 4 bytes or, yeah. And then, I guess we have this total rating and total number. So let's just say we have some big number. I don't know. Let's just say 10 bytes and then something like this is 10 bytes. So what's that total? This is roughly like 30, 50. Let's call it 100. So we have 100 bytes for a business. Let's say each business has on average 50 reviews. And then for each review, you have like an ID, a user ID, all this stuff. So let's say this is like 50 bytes. So let's say like 50 times 50. And then users, which is going to be like the least part. So that I think that we can basically say that's like 0 compared to the rest of this. It's like 2,500, 2,600 or something. I don't know. 2,600 bytes plus 10 million of them, right? So I think a million, like if you just compare like a byte to a gigabyte, so a gigabyte is basically 10 to the 6 or 10 to the 9th even bytes, right? So this is 10 to the what? So a million is 10 to the 6th, I want to say, or 10, I never get it right. Let's say this is 10 to the 7th, so 8, 9, 10 or something like that. So it's like 10 to the 10th. And yeah, maybe I did that wrong, but whatever. Let's say it's even 10 to the 11th. A billion is 10 to the 9th. So this is only like 100 gigs or something. Maybe I did it wrong, but assuming, yeah, if this is like 100 gigs of data, that's like nothing for a database. Because there isn't like too much stuff here. Obviously, you're going to keep adding in more stuff, and if it gets too big, then you are going to need to use something else. But yeah, essentially, we can just fit this in like 1 DB instance, and we should be able to just use like indexing for everything. So I guess what we can do here, and we can talk about it, is for the text search, we can add the gin index. And then for the like location, so yeah, I think these guys had another video on this. You can add a gist index. And that's basically like a geospatial index for Postgres as well. So roughly what that does is so there's like a few different algorithms, I think, for geospatial. But most of them, what they kind of do is they take like everything and then they keep dividing it up into regions, into more regions, into more regions. And then once you get whatever region you want, that data is going to be indexed very well. So you can't use like a default B-tree index, but essentially you will just have a gin index for full text search, and then add, so we can write this, so gin for text and gist for location. And then we don't need Elasticsearch. We can just basically leave it the way it is. All right, let's go with this. And yeah, I basically made like a full text search feature at work, and I know that like gin works because I literally did it. So like the B tree wasn't working well, so I ended up having to do this. Okay. So what we can do here is we can have like, there's two parts of the complex query. The category can just be indexed, that's quickly. The hard part is name matching and the location. And so we can have two indices in Postgres for this because the DB isn't that big. So we can use a gin index for text. It's like a trigram index, inverted index, and that's gonna make our like full text search perform reasonably well. and then we can use a gist index for location, and that's a geospatial index. And I don't know which one Postgres uses by default, but whatever it uses is gonna should be work fine. And then if our data ever gets too big, then we can add Elasticsearch instead. But then we'd have to make sure Elasticsearch is in sync with our DB. Once again, we can have eventual consistency, will be fine. But I think this is going to be like the simpler option for a small amount of data, which is like kind of what we have, I think. Okay. Okay, just consider explaining post. Okay, so it's called PostGIS for geospatial. Okay, provide more detail on how they would be combined. Yeah. Yes, I think I talked about this one already. Well, I guess I talked about it, but not in the thing. Yeah, so how they would be combined. So typically what you want to do is you want to make sure your entire query is indexed. So if you're going to combine like location and then text and then whatever, what you could do, you want to figure out like how to make your table as small as possible. So what you could do is you can like, yeah, I guess we can try it again. I could say this. Let's switch to voice. Okay, so we can have a gist or gin index for text, Postgres gin, and then we can have a Postgres gist for location. And we want our entire query to be indexed to make this quicker. So what we can do is we can first search for all businesses in the location, and that'll be indexed, and we'll be able to get that pretty fast. And then we can search, so that can be like our subquery there. And then we can have a query on top of all of that that will do the full text search over all of those things. So that way the location will be indexed, and then the full text search will also be indexed. And then we can have like a query planner checking all of these things. So we can first try the subquery on location, make sure the query planner is using that index, and then we can have the other query on top of that, which is going to be the full text search. And then the category, we can do last or something. I don't know if it matters too much. Oh, okay. Consider elaborating how you would handle searches. So potential full text search extensions in conjunction with PostGIS. Yeah, that's kind of what I was saying. I don't know. Okay, add Elasticsearch. Okay. So yeah, I guess Elasticsearch is the other way. And then with Elasticsearch, you would every time. Yes, I think with Elasticsearch, what you would do is, I guess they talk about it here. You have an inverted index, which makes full text search good. You have geospatial, which makes like location good. You can also combine, like Elasticsearch is just basically made for searching. And then it looks like they have a change data capture system that ensures that any updates to business are quickly related. Yeah, so we have eventual consistency here. And yeah, basically whenever the database is updated, we will update Elasticsearch to keep it as in sync as possible. And then if it's a little bit off, that's totally fine. Because like I said, for most of these systems, these aren't like trading or money or anything. So if something's not completely updated, totally fine. Doesn't matter. Okay. How do you modify your system by searching predefined names such as cities? Finite list of supported location names. Okay, so yeah, so if you want to search for like specific keywords, like basically keyword search, I think Mongo is good for this, but because we use Postgres, I think the other thing we can do is we can. I think we would need to use Elasticsearch here. And Elasticsearch is also good for this like keyword searching. The inverted index is kind of similar for that. So for every business, we can have like keywords. So we can basically add like Elasticsearch here. And then our search service will just call I guess what would this look like now? So if we search for a all businesses matching something, then that would probably go in Elasticsearch. And if we search for a specific business with like an ID and ratings and all that stuff, I think that's going to be in the DB still. And then, yeah, I guess we can use this like change data capture that they were talking about. I haven't really added Elasticsearch to stuff myself. I know we have it at work for some stuff, but yeah. So what this would work, the way this would work is, I think for a business, you have to give it keywords that because like so if you can search for everything, then this isn't gonna work well. Like if you can search for like SF and like S or whatever, but assuming there's like only a finite, which is kind of what they said. So whenever we add a business, we can just say like keywords. So if we add a business in SF, keywords, then we can just add like SF in California and whatever the things they could search for here to that business. And then we can also add that in Elasticsearch. And then Elasticsearch will let you, like, you can basically give it keywords and say like, okay, this keyword, like this business has these keywords, this business has these keywords, this business has these keywords, and so on. And then when you give it a keyword, it will give you the information. Because I think that's actually how you put information into Elasticsearch to begin with, where you usually like break down all the text for something. So I think that could work. I'm not super familiar with this, but yeah, let's try to go something like that. Okay, so what we could do is for every business, we can also have like a list of keywords. And because this is finite, whenever we add a business, we can just add all of the associated keywords that people are going to be searching for. So if a business has some stuff, we can just make sure like, okay, these are all the keywords that users will be searching for. And then we can have that in Elasticsearch. And then Elasticsearch should be able to quickly give you businesses based on keywords, because I believe that's how like just an inverted index works, is you're breaking something down into a bunch of words, and then when you search for the words, you can get the original thing that you broke down. Let's see how we did. Not quite it. Okay. Consider implementing a pre-computed location, polygonal boundaries for cities. New business is added. Determine all the polygons it falls. Yeah, I'm literally not familiar with this at all. So. Then address had a location names. Okay. Yeah, I guess for this one, let's just look at the sample answer and let's read it, because I don't know this one super well. So, pre-computed location matching system. We'll store polygonal boundaries. Okay. The polygons accurately represent the geographic areas. When a new business is added, we'll determine all the polygons it falls within. This might include a city or some other stuff. We'll then store these locations within the business record in our database in Elasticsearch index. For example, in business in San Diego or San Francisco Mission District might have location tags. Okay. Okay. When a user searches, we'll match against these pre-computed locations. This is fast because it's just string matching. Okay. Speed and accuracy, we're not doing any heavy. Okay, so I guess that's what we missed, is we didn't really figure out like how to actually get these like these keywords. So I guess that makes sense. We can, yeah, so essentially on a map we can put polygons or like shapes for everything. So like San Francisco will have like a polygon, San Diego will have a polygon, like California, US, whatever. And then wherever that business, the lat launch falls into, like whatever polygon it falls into, every single keyword it falls into can just be put on quickly. Then makes sense. Yeah, definitely not super familiar with this. Also seems pretty hard. So yeah, no. Okay, it's complete. Oh, it's pretty good. Site growths. Okay, so takeaways. Okay. So this is pretty good. Okay, race conditions, data consistency issues. Be specific about database constraints. Indexing techniques. I think I did that for some of it anyway. Consider trade-offs. Postgres extensions. Last search did that as well. Maybe just didn't say it. Focus on accurately representing geographical data. Okay. Let's just go to the solution, see if you miss some stuff. So, constraints, quantities. Okay, we got all that. Business. Reviews. Okay, leave a review. Yeah. High level design. Okay. Looks like what we had. View businesses. So, yeah. Leave reviews. Okay, so they kind of did this. They split it up. Yeah, that's generally what I found is like the easiest. Just split it up into services, and then there is a downside, obviously, in like real work, where if you split it up into too many services, you have to like maintain it all. But it's gonna be like easier to scale in like a system design interview. Okay. Right. Yeah. So aren't all microservices? Yeah, and this can you can kind of go a little bit crazy here, where you can give every microservice its own database, but sometimes it's just not necessary. So that's like a call you have to make. Okay, so periodic updates with cron job or optimistic locking. Okay, so they used the old rating. Yeah, I just gave it a number, so kind of similar. And then yeah, cron job makes sense as well. So you literally just update like yeah. Honestly, like it would be fine to do either. I think these two, it's like whatever is easier to implement, because it doesn't really matter. Like if a business's review isn't completely up to date, like no one's gonna know. So. Okay, application. Yeah, I think this one's pretty easy. Improve. Last search, Postgres. Okay, so which one do they use? Create PostGIS. Yeah, this one right here, PG trigram. And this is the trigram index that you can use for full text search. And I haven't used this one in practice, but. And then 10 million. I guess maybe I did the miscalculation wrong or something. Okay, they got a terabyte. I think I got like 10 gigs. But either way, it's like nothing. So, okay. And yeah, this is, I think this says this as well. Like, once your scale of data is big enough, then you probably want to use Elasticsearch. I mean, Elasticsearch is probably just better overall, but there's just like more maintaining and it's another system and you have to keep it in sync. So. And I think actually when I was doing this at work, this is like what we talked about. Some of it is like, if we add Elasticsearch, it's like more work. So is this worth doing? And decided no. Okay, staff level. Okay, well, I'm not that, so that's good. Locations, simple radius. Okay, so yeah, polygons, GeoJSON. Yeah, I'm not familiar with this at all, so I guess I'll look into this later. Okay, but yeah, essentially you make, okay, so you make a table with polygons, and then you index the name for, okay, I see. Yeah, I'd have to look into this more, but yeah, okay. So at least got most of it. Okay, so yeah, I'm gonna leave it there. Let me know what you think in the comments, and yeah, let me know if you like these types of videos. So I'll see you in the next one. Thanks for watching.